Hi everybody, Dr. Gustin here. One of the best ways to learn about the ear is just to look at a diagram, name the parts and what they do as a sound wave comes in. Remember that sound waves are physical vibrations, and so the kind of receptors that detect sound waves are mechanoreceptors. And most of what we consider the ear are parts that get those sound waves directed and concentrated to those mechanoreceptors. So let's talk this through. And I would recommend you try this as a way to practice this information. Use the picture. So the part of our ear that we see on the outside and we think is cute and we like to hang earrings on is called the pinna. Some people call it the auricle, but our book uses the word pinna. So that's typically what we've called our ear, but that's really only what you see on the outside. And if you look at this whole section A, that whole section is what we would call the outer ear. So it's the pinna and the region in which you could potentially stick a Q-tip and access it from the outside. So here we have the pinna, and if we have sound waves, the sound waves are directed by that pinna, almost like a cone, into this passageway that we call the auditory canal. And those sound waves then are directed towards the first membrane called the tympanic membrane. And that can actually vibrate in response to the sound waves coming in. The vibrations of the tympanic membrane, you might call that the eardrum. The vibrations of the tympanic membrane or the eardrum cause vibrations of these three little bones. These little bones collectively are called the ossicles. You might have heard them called the malleus, the incus, and the stapes, or the hammer, the anvil, and the stirrup. I'll just call them by their general name, the ossicles. Now notice that this section B falls right into this area, and that is the middle ear. Now, the only way to get to the middle ear is through the auditory tube. Now, you might call that the Eustachian tube, and that tube actually connects your ear to the inside of your pharynx, your throat, that's above your soft palate. So if you stick your tongue on your roof of your mouth, you have the hard palate, and then put your tongue further back, and you can see that it's kind of flexible. That's a soft palate. So these auditory canals come in above the soft palate into your pharynx, into your nasopharynx, the throat that's kind of attached to your nose area. So the only thing that can get in there is something that's coming through the pharynx, through the throat. And typically the middle ear is filled with air. And you've probably heard of people getting middle ear infections where they get fluid in there and bacteria, and it can cause pressure and pain. But normally this auditory canal is, it's just there to regulate air pressure in our ears. If you swallow, you can hear some little clicking sounds. Those little clickings are the opening of this auditory canal. When you drive up to campus, on Spencer Hill campus, you might hear your ears pop. That's the opening of this auditory canal, equalizing the pressure in the middle ear with that of the surrounding environment. So those vibrations, those sound vibrations that vibrate at the tympanic membrane, then vibrates the ossicles. And then under this last ossicle, there's a little membrane that's called the oval window. So the ossicles cause the vibration of that oval window. So now we've taken sound waves that are as big as your pinna, and we've concentrated them into smaller and smaller and smaller areas till now we're using all those same sound waves to vibrate this oval window. Now the oval window is attached to the side of section C here that we call the inner ear. The inner ear is all bony. It's surrounded by bone, and this is where our receptors are. So it turns out the inner ear is the only part of the ear that contains fluid. And the receptors, remember, modified dendrites can be receptors. And so it turns out the receptors in our inner ear are actually what we call hair cells. They're kind of like little tiny hairs. And so you can imagine a fluid with little tiny hairs little tiny hairs surrounded by fluid. When the fluid vibrates, it causes the little hairs or the hair cells to vibrate. And so that is stimulating the receptors. So we've got the vibration of the tympanic membrane, causes the vibration of the ossicles, causes the vibration of the oval window, the membrane under the last ossicle, causes the vibration of the fluid in the inner ear, and then causes the vibration of hair cells. And the part of the inner ear where there are hair cells or receptors for sound is this curlicue called the cochlea. The vibration of those hair cells in the cochlea in turn vibrate this thing coming off there, or actually don't vibrate there, but they actually trigger an impulse in this, which is the auditory nerve. And that's going to carry that information to the brain, and that's going to be interpreted as sound. So I'm going to do it quickly. This might be a place where you would stop the video and just back up to this point, but I'm going to do it quickly again. This is what you should be able to say. Sound waves are directed by the pinna into the auditory canal. They vibrate the tympanic membrane. You can also call that the eardrum. That vibrates the ossicles in the middle ear. The last of the ossicles vibrates the membrane called the oval window, which is on the outside of the inner ear. That's going to vibrate the fluid inside the inner ear, particularly the cochlea. It's going to stimulate the hair cells, which are the receptors in the cochlea, and cause an impulse to go up the auditory nerve to the brain. Practice that a couple times. The only other parts we had here is the inner ear is also sensing balance, and there's a part here in the middle, we called it the vestibule, that has receptors or hair cells that pretty much tell us which way's up and which way's down. Okay, so even when our head's not moving, it's sending information to our brain through this same nerve to tell us which direction's up. What position are we in when we're not moving? These three loops are called semicircular canals. They're also filled with fluid and hair cells. And if you've ever seen a level that we use that has the little fluid in it and the air bubble, and as you move it, the air bubble moves, that's the same thing that's going on in these semicircular canals. As you move your head, different receptors are triggered to tell your brain which position your head's in, so you can tell where your body is. If you want to do it one more time, let's try the sound waves. Okay, you should be able to say this. Use the picture. Sit there with the picture. Sound waves are directed by the pinna into the auditory canal, which vibrate the tympanic membrane and in turn vibrate the ossicles. The ossicles vibrate the oval window, and that's going to vibrate the fluid inside the cochlea and trigger the hair cells, which are the receptors for sound. Those receptors are going to send impulses up the auditory nerve. Both the vestibule and the semicircular canals in the inner ear are also contain receptors for the position of our body, whether we're not moving or we are moving, and they will also send information through triggering hair cells up this same nerve to the brain. Try it. Good luck.